Hello everyone, my name is Alonso Unzueta, and today I'm going to present you the programming part of our project, that is the reactor automation for chemical products. So for instance, we are going to follow the next order. In the first place, we have the type of programming that we are going to use, then some structures of our program, then some routines, and finally, digital and analog inputs and outputs. So let's start with the type of programming. The type of programming that we are going to use is based on C++ language. C++ is a multi-purpose programming language, and it is one of the most efficient. And also Arduino is based on this structure, on this language. But why are we going to use this type of language? Well, we found some reasons, some advantages at the hour of use this language. And the first one is portability. C++ is portable and can be used to develop applications that can be adapted to multiple platforms. Then we have the memory management. In this part, we can use as many memory as we want or as we need. Of course, there is a limit of memory space in some controllers, but in most of the cases, we can find enough space to develop our application. Well, for practical application, for practical projects, but also for more hard or more difficult applications, we can find the enough space to develop these projects. Then we have the mid-level programming language. In this part, it means that our programs or applications, it will be as well at the hour of creating this. It will be as easy or hard as we want. It will be depends on the applications or the purpose of our programs. Then we have the standard libraries. In the case of Arduino, we can find the many libraries to use modules, to use sensors, to control many actuators. Then we have the fast and powerful. Well, let's start with some structures of our program. Well, with the principal or the mainly structures for program. The first one is the if structure. These structures allow us not only to check the signal from the load cell, but also from another sensors. But in the case of the load cell, it helping us and the operator to establish ranges within the condition. Then we have the switch case. This structure is very related with the menu options. It will work through the LSD display to show the options. Then we have the while structure. This structure allows us to execute a sequence that will continually execute the function inside it until the conditions for terminations are reached. Then we have some routines of our program. Our program is divided in three specific routines. The first one is the quantity selection. In this routine, the quantity of each container will be selected through a series of buttons and the options given by the menu in the display. Then we have the weighting part. In this routine, the selected material will be weighted by the load cells and verified by the controller. After that, a signal will be sent to the relays, and then the relays will activate or deactivate the solenoid bulbs. The third one is the dispensation. In the routine, after receiving the signal of each material weighted, the solenoid bulb will activate and let the material flow to the main tank, where the mixer will be mixing everything. Well, let's start with the digital inputs and outputs. In our project, we are going to use three solenoid bulbs that are we going to be connect to digital outputs, since they will only be working with high or low signals provided by the relays. Then we have our buttons, our push buttons that will be connected to the digital inputs. Since when we are using them, they provide a high or low signal, which will be read by the controller. Then we have the display that are we using. Works in a digital output, since it only works by high or low signals. And then we have the analogic inputs and outputs. In this part, the load cells that we are going to use are going to be connected to analogic inputs. In this case, the controller, it will be read the signals provided by the cell, and it will be read through this input, this analogic input. Well, in our case, the load cell will weigh the raw material and then convert them into voltage and send those values to the controller, and then the controller interpret this voltage into some information. Finally, we have here some parts of our program. In this part, we include some libraries to control, to communicate with the load cell. In this part, we define the variables. Then we create the object. Well, as you can see, we can find some structures, void structures, if structures, while structures through all the program. In this case, in this part is where it starts the process of adjustment and calibration, and we are using a while structure. Then in this part, we are looking for the weight of that is provided by the weight well, by the load cell, we use if structure here. Then in this part, we select the weight reading by the controller, and we are uh, using again the if structure um, to show the the options on the display. Then in this part, we include the library to work with the LSD display. We define the inputs or the outputs to work with the display. Then we start with the void setup and include the LSD features here. Here we have again the if structure. In this part, we are going to read the signals provided by the push buttons. In this part, we are using the while structure to again to show some information in the LSD display. Again, here we are using the if structure to change some values to in the LSD. Well, to select an option on the LSD. Sorry. Again, well, it's just to select or to change the option provided by the display. Well, that's it from my part, and thank you for watching. Goodbye.